Welcome to this video. In the previous video, we have seen the multiple access protocol Aloha and its versions pure Aloha and slotted Aloha. We have seen there the throughput of pure Aloha was 1 upon 2e and that of slotted Aloha was 1 upon e, which was double than that of pure Aloha. Even though that was better than pure Aloha, it is quite low. And this is because the senders do not check whether the other stations are transmitting, so that there may be multiple collisions. So if the senders can check whether other stations are sending or not, we can decrease the chances of collisions. And that's how we will now see the carrier sense multiple access protocol or protocols, the versions of that, wherein the senders can sense whether the other stations are sending or not. So protocols in which stations listen for a carrier, that is whether some stations are transmitting or not, and accordingly they send or defer their transmission. So these protocols are called as carrier sense protocol. The senders have got the sense of the channel or other stations, you can say. There are several versions of this CSMA protocols, which are categorized into persistent and non-persistent CSMA and CSMA with collision detections. So the second category, CSMA, carrier sense multiple access protocol with collision detections, has also got a further characteristics of detecting or being able to detect the collisions quickly. So we'll see both of them today. The first such CSMA protocol is one persistent carrier sense multiple access CSMA protocol. So here, when a station has some data to be sent, it first checks the channel, listens to the channel to see if any other sender is transmitting at that particular moment. Now, if the channel is idle, the station sends the data. Otherwise, the station just waits continuously until the channel becomes idle. So this is very important. If the channel is idle, it will send the data, and if it is busy, that means some other station is using that. That is known because this is CSMA, carrier sense multiple access. That's why if the station is busy, this sending or the station willing to send the data will wait until the channel becomes idle. Now, in that case, if a collision occurs, now this may still occur, we'll see. The station just waits a random amount of time and starts all over again. Now, this protocol has problems with collisions. We'll see now why collision can still occur. Now, imagine there are two stations willing to transmit. Now, as they find first some other station is transmitting through the channel, they'll be patiently waiting until the channel becomes idle. And once the channel becomes idle, both of these stations will start transmitting at the same time. And this is the reason why they will once again collide, or their frames will collide. If they continue, the collisions will also continue in the same way. The second possibility is of propagation delay. If the propagation delay is large, for example, and if a station is checking for the channel, the station may not detect that a station has already started transmitting its own frame, and that's why this station will also start transmitting its frame, and that's why these frames may collide. So this is a subtle possibility of collision when the propagation delay is large. Now this version is called as one persistent CSMA because the station will transmit with a probability of 1. That means the highest probability. That means it will surely transmit when the channel is found to be idle. And that's why this is called as a greedy version. The station seems to be greedy. It always tries to utilize it. The next version is non-persistent CSMA. Here the transmitting stations are found to be less greedy. That means they will not transmit at the probability of 1. The transmitting station here will send the packet if the channel is found to be idle, but if the channel is already in use, here the station does not continuously sense it for transmission, which was done in the previous case of one persistent CSMA. Instead, it waits a random amount of time and then repeats the algorithm. This is the difference of non-persistent with CSMA. So next version is P-Persistent CSMA. Here this particular version applies to channels which are slotted or slotted times are there. Here the transmitting station will send the packet if the channel is found to be idle with a probability of P, some P. Alternatively, it will not send or it will defer the transmission with a probability of Q, which is 1 minus P, until the next slot. So it will transmit if the channel is found to be idle with a probability of P. Otherwise, it will defer with a probability of Q, which is 1 minus P, until the next slot. Now, if that slot is still empty, the next slot is found to be still empty, it may transmit with a probability of P, or it may not transmit with a probability of Q respectively. If the channel is in use, that means some other station is already transmitting its own frame, this station will treat this situation as a collision, and then it waits a random amount of time and then starts all over again. This is what is called as P-Persistent CSMA. So here we see the plot of G, the attempts made of per frame time against the throughput, the channel utilization S. So here we get to see that, as usual, the least utilization is given by pure aloha. Still better is given by slotted aloha, as we have seen previously. But the CSMA protocols have got the higher utilization or channel utilization, we can say, with one persistent giving going above pure aloha, as we have discussed previously. Then comes 0.5 persistent CSMA. Then comes 0.1 persistent CSMA, then non-persistent, and at the most level, the most channel utilization is possible with 0.01 persistent CSMA. Here the figures like 1, 0.5, 0.1 and 0.01 are all the probabilities with which the channel will try to send the frame or transmit. Now still advancement can be taken by attaching a capability of collision detection with CSMA. Now in CSMA, the stations have got the carrier sense, that means they can check whether the other stations are already transmitting or not. But when the collisions occur, uh, the frame transmission continues, and this is how the bandwidth and time is wasted. So if the channels or the station detect that the collisions have occurred, and if they immediately stop transmitting the rest of the frame, they may save the time as well as bandwidth. This is what is called as CSMA with collision detection, or in short CSMA oblique CD. Now this is a basis of classical Ethernet LAN. This is used in classical Ethernet. The transmitting station is reading the data that it is transmitting. That means it is checking whether the data has correctly gone through. If the data has been garbled up, then it will know that the collision has occurred. So this is what is shown here. So in this diagram, we can say that the CSMA CD can be in either of these three states: contention, transmission, or idle. So let us say, for example, at time t0, a station has completely transmitted a frame. The time goes like this. So at time t0, one station has finished transmitting its frame. So that's a transmission period. Now, if other stations are willing, they sense that now no other stations are transmitting, so multiple stations can have a contention for their transmission in their slots, in this slot. So this is what is called as the contention period, where the stations detect that now no other stations are transmitting. That's why they start transmitting their own. So this is what is called as the contention period. If only single station is transmitting here, its frame will be transmitted successfully. But if multiple stations simultaneously start to transmit, there will be collisions. And if there are collisions, rather than finishing that particular frame, those particular frames which have been collided, because ultimately otherwise there may be a single bit collided, or there may be a major fraction of the frames collided. This is going to be a waste, and that's why once detected, they will detect that the collisions have occurred quickly, and once it is detected, they will immediately stop. This is the change. They will not finish off sending the rest of the frames. This is how they save the time and bandwidth. And now they will wait for some random amount of time, and once they detect that the channel is not being used in their own slot, some station will start. So once again, there may be successful transmission, there may be contentions, or there may be some collisions, and there may be sometimes, if no station is willing to transmit, idle period as well. So in CSMA CD, collisions do not occur once the station has unambiguously captured the channel, that which is shown here. Because once the station has started transmitting in its slot, this will be detected by the stations, other stations, and they will not start in that period. But the possibility of collisions can be there when the stations detect that after the frame has been completed and more than one station become active for transmission. There may be the possibility of collision. And that's why the collisions can still occur during the contention period. That will not occur during the transmission period. So these collisions adversely affect the system performance. Basically, if the bandwidth delay product is large, where that will be large when the long cables with large propagation delay are there, and frames are short. So this will adversely affect the system performance. So today we have seen the second multiple access protocol, CSMA, with collision detection capability as well, and the versions of those like one persistent, non-persistent, P-persistent, and lastly CSMA CD. Thank you.